So one reason why this packet is so big is I did copy like a lot of like concepts in there. It's not very good. Thank you. Anyway, this little section is talking about if we are solving an equation and the root that we have or that we do to both sides. Remember when we solve an equation, we like square root both sides to solve for x. We'll do that with other roots. If it is an even root, then you cannot take the even root of a negative number, just like you can't take the square root of a negative number, it'd be imaginary. If it is even, you would do like the plus minus and from. If it is odd, you can take the square root of a negative, and that's the odd root of a negative. And there would just be one answer. You're not going to do plus minus when you have odds. If it's negative, your answer is just going to be a negative answer. We have some examples over here. So that's kind of what this is saying here. And then this part right here is the part that is going to keep occurring in here over and over again. When you have a rational exponent, what does rational mean? Fraction. That's what it means. Ratio. Fraction. Rational means fraction. So when you have a rational exponent, we're going to have a fraction exponent. Here's an example right here. A to the m over n. When you have that, you want to think of these two numbers as two separate things. You want to think of the n as the root. And you want to think about the m as the power. And we can remember that the bottom number is the root. How can we remember that the bottom number is always the root? Because roots grow in the ground. Roots are on the bottom. Power is up top. You can think of like, those power lines. But if you remember the root is on the bottom, then the other one's the power. So when we have a fractional exponent, it is completely the exact same as writing it as a radical. They're the exact same, it's just a different format. So these are completely interchangeable. Sometimes it is more convenient to make it into a radical, sometimes it's better to make it into a fractional exponent when we are simplifying. These examples just say to take the nth root of that number. So where it says n is 3, that's saying please just take the third root of negative 125. So what to the third power is negative 125? Negative 5. Do we know these numbers? Maybe, maybe not. Let's make a quick list. If you don't know that 5 to the third is 125, you might want to jot down some numbers. 2 squared, or 2 to the third, 2 to the fourth, 16, we're multiplying by 2 each time. Yeah, thank you. 32, 64, I didn't write that. 128. Do one more. 28. You don't have to write it down. But it does say do stuff without a calculator, so that's what I'm writing them down. 3 squared is 9. 3 to the third is 27. 3 to the fourth, 81. 3 to the fifth, if you didn't have a calculator, you would take the previous number and multiply it by 30. I didn't hear it say. 30 to the 6. Okay. 4 to the second. 16. 4 to the third. 56. It's my elbow when I stand on that side of the board. The 4s are 4 is the same thing as 2 squared. So when you look at the 4s, those numbers are already like in the 2s. 5s, just do a couple 5s. 5 squared, 25. 5 to the third, 125. 5 to the fourth, 625. And you can make your own list. So if you're taking a quiz and it's like no calculator and you need to know what 4 to the third is, you could take 4 squared and multiply by 4. You can find the answers. Okay. So going back to this. This one says take the what root? Square root of negative 400. Not a real. And I'm not finding the imaginary because it doesn't say find it. It just says find any real ones. So we don't need to do that one. And then the last one, we're doing the 6th root of 64. But since I am putting in the root myself, and this one's even, this one could be plus or minus. It's kind of like I'm solving an equation where I don't know if it's going to be plus or minus, so it could be plus or minus here. All right, the next section is no calculator. And there are different ways of doing these. But I'll probably do it the way that I think is most efficient. So 64 to the 1/2, I would probably change that into a square root. Right? The root is 2. So square root of 64 is 8. Number 5. What's the root? The root is 3 of negative 27.
So it can be plus or minus 8.
Yeah.
Oh, no. And the reason why is, even though it doesn't look like a radical, the radical's already there. I didn't put it in. I just changed the form. So it's just when you're solving, like when you get to numbers, you turn the page to like number 16, that's when you would use the plus minus when you're solving. Not when you're evaluating. So when you're evaluating, they've already given you the radical, even though this is not a radical, but it is. It's just in a different form. Yeah.
So welcome for, you said for using
When you're solving. We're not like solving, we're just evaluating what's already there.
Oh.
So if you look at this one, the negative is already there, right? It's whatever sign is in front, because we're just evaluating. If it says solve it, that's when you would use plus or minus. So if they're asking for roots, that's what
It says at the top for odd, and if you're, when X is odd, and there's never a goal to put plus or minus.
correct.
So when we're solving, we'll never have plus or minus for odd.
Correct. Yep. And we are solving. It just is on the next page, so we'll do some. These right now are just manipulating. This is just practicing with our rational exponent and simplifying. So coming back to here, that one's going to stay positive. This one here, we're saying what to the third power is negative 27. Negative 30. The next one. So you have a choice. You want to think about the power and the root separately, but you have a choice. You can either do the power first, or you can do the root first. So you can either do 32 to the 7th power by hand without a calculator first, or you can do 32 with the 5th root first. What do you think is going to be easier? Let's do the 5th root of 32 first, and then take that answer to the 7th. So we're separating the power and the root, so that we can do this without a calculator. What's the 5th root of 32?
Cancel the 5 and then just do 32 squared. Like subtract the 2.
No. That we are going to do today, but that's when you have like when you have bases that are the same and they both have exponents. That's what you're thinking of there. Okay. So this one we're going to do the 5th root of 32, which is 2, and then take that answer to the 7th. So I don't know if we wrote that. Yeah, we wrote that, didn't we?
Yeah, that's 120.
120. And if you didn't, well, then you multiply 2 times 2 times 2 times 2. Next one is 49 to the negative 3/2. So will I want to do the root first or the power first? I'm going to do the root first. I think it'll be easier to take the square root of 49 and then take that answer to the negative 3. Square root of 49 is 7 to the negative 3. What does negative exponents do? Yeah, it starts with an R. What's that? Reciprocate. The negative exponent means to reciprocate it. So instead of 7, it will be 1/7 to the 3rd, or 1/7 to the 3rd. And then at that point, well, I don't know what 7/3 is. I know 7 squared is 49. I multiply it by 7 by hand. I got 343. 1/343. So next one, negative 32 to the 3/5. Should we do the 3rd power or should we do the 5th root? 5th root first. So we're going to do negative 32 to the 5th root and then take that answer to the 3rd power. So the 5th root is negative 2, so the 3rd power is negative 8. Oh, we forgot to talk about the thousands. That's it. Thousands are the easy ones. We're going to take the 3rd, or take the 3rd root of 1,000, and then raise that to the negative 2. That's 10 to the negative 2. What does the negative exponent do? Reciprocate. And then we just do 10 squared on the bottom, 100. So is this stuff coming back a little bit? Because last time we talked, you've never seen it ever. You've never seen negative exponent? Yes, you have. There's no way that you did not do that. Okay. 81 to the 3/4, what should I do first? Fourth root. Roots grow in the ground, so they're on the bottom. So 4th root of 81 is 3 to the 4th is, just kidding, to the 3rd I mean, 27. And then the last one looks like it's 4th root of 625. It ends at a 5, so that gives you a big hint what that number is going to be. All right, excellent. We're going to skip the matching sections. If you want those answers, they're on Canvas. Let's do the solving. So first, number 16, we're going to divide by 6. You're going to get x cubed equals -1. And then how do we cancel out an x cubed? Cube root. And if I do cube root, do I do plus minus? No, not with odd. So we just have x equals. What is the cube root of -1? It's -1. Any root of a 1 is going to come out being a 1. Any odd root of a -1 is always going to be -1. Can't take an even root of -1. Why? This negative, and it would be imaginary, right? All right, next one, we're going to divide both sides by 2. We get x plus 5 to the 4th equals 64. Then what do we do? Okay, we're going to do the 4th root, and this one is a little tricky. Doesn't look like it, but it is. If I do an even root, I need plus or minus. Is there a 4th root of 64? 2 to the 4th, is that 64? No, it's not. 3 to the 4th? 4 to the 4th? 5 to the 4th? No, we're like way past 64 at that point. So instead of having an actual like easy answer, we're going to simplify this. This says round. We're not going to do that, by the way. I meant to get rid of that in your direction. Sorry. It's not in your homework direction. So instead, we're going to simplify. We're going to break it down. But when you break it down, you want to take 2 4th roots that multiply together to give you 64. One of them is a perfect 4th root. 16 times what? 4. So I get x plus 5 equals plus minus 2 4th root 4. But I'm going to tell you right now, that one is not simplified all the way. It kind of looks like it is. But you may be able to simplify it a little bit further. Check this out. 4 is the same thing as 2 times 2, or 2 squared. Right? And if I take this and rewrite it in exponential form as a fraction exponent, if I take that and I rewrite it as 2 to the 2/4, it's 1/2. And then I'm going to put that back into radical form. So I plus minus, I have that 2 out front, and now I have the square root of 2. I lost you through the entire thing.
Yeah, like that entire last step, taking it out and putting it back. But it's fine, you don't have to go through.
Well, what is this right here?
Important root.
So I put it on the bottom, because that's where roots are. And then that's the power. So what on top, and then I just reduced. 2/4 is 1/2. And then I think 1/2, that is the root. And that is the power. So this is a square root and 2 to the 1st. That other 2 just came down. Last thing I'm going to do is I'm going to move my 5 over, and then we'll be done. I would say that would be the most challenging, confusing thing that you'll have, is making sure you've simplified it all the way by thinking about if you can factor what's underneath that radical, if you can factor it further. I know that's going to be in your assignment. Okay, so when you work on your assignment, I should hopefully give you some time in class to start it, and then you can ask questions about that too. Okay, so this one here, we're going to add the 32. We're going to get x to the 5th equals -32. Then what are we going to do?
The fifth root.
Fifth root, and if I take fifth root, do I need plus minus?
No.
And is there a fifth root of negative 32? This one over here, we're gonna take away the 100. We're gonna multiply both sides by negative 10. We're gonna cube root it. And get 10. I didn't hear you. Oh. Well, 10 times 10 is 100. 10 times 10 times 10 is 1,000. The number of zeros is. Yeah. I meant to do it when we were listing all those other ones that I forgot to put down. Okay, before we go on to the next section, I know there's one that's a little challenging in homework, so instead of me answering 20 individual questions, let me just make up a question that's similar to the one in homework. Oh, I didn't mean to do that. Okay. If we have to do something like x to the 7th equals negative 6, what would you do to both sides? You're going to do the 7th root. So we'll have x equals the 7th root of negative 6, and does that simplify? Yes, it does. Because negative 1 will always have a root. So if there's a negative under there, even if I can't do anything with the 6, that's okay. But that negative 1 can pull out when it's the odd root of a negative number. That negative 1 can pull out. So we'll have negative 7th root of 6. So there was something that we could have done to that. That was not there. There's one similar to it in the homework, and I had to answer 20 questions already yesterday, so I figured I'd just give an example like that to you. Questions? Good? You got it? Okay. Let's see. We're going to skip some of these next ones. These are just examples. I'm not going to do all of them. But just to help you remember some of these rules, let's do number 3. When you take a monomial, one term, there's no plus minus sign, so I'm not going to be FOILing or anything. It's just one term. And you square it. You could, if you want, write it twice and then multiply all the stuff together. Or there was a shortcut. When we take stuff inside to a power, what can you do? Multiply the exponent. So we don't just multiply, we multiply the exponent. So like for the first number, 5, is the answer 10? No, so we don't just multiply, we multiply the exponent. So it would be 5 squared, which is 25. It would be 5 squared when you multiply the exponent. The next one would be a to the 6th, b to the 20th, and c squared. So if you are raising it to a power, you multiply.
Wait, number 1 would be
Yeah, so there's one that's more complicated, but it's similar to number 1. I'm just going to do a more complicated one if that's okay. But yes, number 1 would be k to the 5th. You see it? Number 1 would be k to the 5th. Okay. Number 4, when we have more than one thing happening, we have to remember our order of operations. First order of operation is parenthesis, but you go inside of the parenthesis, there's nothing to do. Our next order of operation is exponent. So what we're going to do is we're going to do that fourth power before we multiply together all the parentheses. So I'm going to bring down my, I'm going to change colors. I'm going to bring down my 3x cubed y, multiply that by, then I have to take everything to the fourth power. So what does 3 change into? 81, not 12. We do 3 to the fourth, 81. X to the fourth, y to the 8th, and z to the 4th. And then bring down the 3x, y, z. Now it's multiplication. And there's no addition, there's no subtraction, so it's just straight. Put everything together. It's multiplied all together. So I'm going to multiply the 3, the 81, and the 3. If I'm doing this by hand, it might be easier to think about, well, I guess I could do 81 times 9 by hand. Or if I have my powers memorized, 81 is 3 to the 4th, and it might be easy to say, oh, that's 3 to the 6th, all the 3's, which is 700. If you have those numbers memorized. Otherwise, you just multiply them out. X's, we've got 3, we've got 4, and we've got 1 more. So I have how many X's total? X to the 8th. I've got Y to the 10th and Z to the F. And number 5. Order of operations, we're going to do our exponents before we multiply together. The first one's fine. The second one, if we do negative 2 to the 3rd power, what is negative 2 to the 3rd? Negative 8. And then we have g to the 3rd, j to the 9. Then that last parenthesis. What number is in front? It's a negative 1. So you have to remember when you're doing the 4th power, you have to do that to the negative 1 also. Because what happens to negative 1 to the 4th? It's a positive. So you'll have a wrong answer if you don't remember about that. And then we have g to the 4th, h to the 4th, j to the 4th. And when we combine everything, we're end up getting a positive 8, g to the 9th, h to the 5th, and j to the 13th.
What did you take out the negative 1, the very first one?
Well, I mean, it's there. It wasn't very. So, the second is not on the negative 1. There's no parentheses, so the second is only on the g, right here. It's only on the g, it's not on the negative. If it were on the negative, good question. If it were on the negative, it would look like that. So those parentheses are really important where they are. Okay. The matching, I'm going to skip it. What are these things? The properties are in the notes, they're defined in the notes. We're going to skip this page. Good. What? You don't have to memorize the properties. They're pretty self-explanatory. Like the negative exponent property is the one that has a negative exponent, or the 0 property would be something to the 0. Like they're pretty easy to figure out. But later in your notes are all the properties. So if you want to go test yourself and see if you know the properties, I'm not going to give you like a vocabulary quiz. It's just there for you if I'm talking about the power of a power property and you're like, what? It's in your notes. Okay. It's more important, not that you know the name of the property, but that you know how to do each property. So this first one, we have 5 to the 2/3 times 5 to the 4/3. So when we have the same base and we are multiplying, what do we do to the exponents? Okay, when you are multiplying, you will never do the exact same thing to the exponents. That is happening in the problem. So if I'm saying we're multiplying, you're not going to multiply the exponents. Okay, it's never the same. So if we're multiplying, you're going to have the exponents. Okay, so we're going to have 5 to the 2/3 plus 4/3. which is 5 to the 6/3, which is 5 squared, which is 25. I see mistakes where people know the rule where we add them, but then for some reason they also multiply the 5s. You keep the same base, you just add the exponents. You keep the same base, you just add the exponents with that trick. So the next one, 3 to the 1/5 times 3 to the 4/5, same base. Add your exponents. We get 3 to the 5/5, which is 3 to the 1st. Okay, the power to a power property is where we have an exponent to an exponent, and what do? We multiply them. So I'm not going to power them if I'm already powering it. I'm not doing the exact same thing. I'm going to do multiplication. So we're going to be taking 4 to the 2/3 and multiply that by 3, which is over 1. And how do we multiply fractions? Straight across. So we get 4 squared. 16. Again, power to a power, we have 10 to the 4/2, which is 100. Then when we have the same bases, and we are dividing, this is what, Mackenzie, you asked me about earlier. When we have the same bases, and we are dividing those same bases, we subtract the exponent. So we'll have 8 to the 5/2 minus 1/2. You do not change the base. You stay with the 8. You just change the exponent. You get 8 to the 4/2, which is 64. So I have 7 to the 2/3 over 7 to the 5/3. So we're going to subtract our exponent. 7 to the 2/3 minus 5/3. So we get 7 to the negative 3/3, which is 7 to the negative 1, which is what? 1, 7. I know it's long, I'm sorry. Okay, I won't do all of the radical ones. I'm just going to do a few. What's the rule if you have the exact same radicals and they're multiplied? You can just multiply them underneath the same radical. So we have 36, which is same rule applies if it's like cubed. So for this one, I'd have the cube root of 5 times 25. And I don't even have to multiply those out. I don't have to multiply those. Because this is 5 to the 3rd. This is 5 squared times another 5. And if I have a power of 3, if I have a power of 3 and a root of 3, those cancel each other out and you just get 5. You can multiply them together and get 125 and take the cube root of 125 also. I'm just showing you other ways you could find answers. Okay, I'm going to skip that one. Division is kind of the same way. They're the exact same root. Square root of 98 over 2. And the reason why I'd want to do that is because what's 98 divided by 2? So now I have the square root of 49, which is 7. So if they have the exact same root, third root of 625 over 5, which is the third root of 125. Okay, here you go. What?
Are we skipping E?
Oh yeah, we're skipping around just so I can get through this as quick as possible. for something like A, when you multiply these together, you get 162. And is that a perfect square? It is not. So that's the kind where you then would have to simplify and do 81 times 2, so that's not equal to 2. I'm going to skip. I'm going to go to C. Okay, so the reason why I'm doing C does not have inside the same base. So I can't combine those. But it is multiplication, so I can take everything in the square. So I'm going to do 5 to the, what do I do with the exponents when I'm powering it? I multiply them. So I'm going to have 5 to the 2 over 2 multiplied by 16 to the 2 over 4. So that's going to give me 5 to the first times 16 to the half, which is the square root. So 5 times 4 is 20. Almost done. We're not doing the whole packet, by the way. I didn't know if you knew that. So that's all those properties that we skipped earlier. And those are the properties with roots. Okay, for these, I definitely want to do a couple of these. Just a couple. Let's do 3. Just do these 2. Number 3. Do you see how they're both to the 5th on the inside? So you can take that 5th out. So I'm going to rewrite this as 52 fourths to the 5th power, but then there's already a 1/6 power out there, so I have to multiply them because it's power of a power. And then I can divide 52 over 4. 13 to the 5 over 6. And that's it. Yeah, there's nothing else we could do with that. So thinking about that, same kind of idea, what do all of these have in common? All of the third on the bottom, so I'm going to pull out that third. This one's going to take up a little bit of space, just so you know. So I pulled it out, it's 1/3. And then what I'm going to do is I want to make this as simple as possible. So I'm going to take like 27, I'm going to take 8, I'm going to rewrite it as a prime number to an exponent. So 27 is what to the what? It's 3 to the 3rd. So I'm going to rewrite this as 3 to the 3rd, but there's already a 2 up there, so times 2 up there. I'm going to do the same thing to the 8. 8 is the same thing as 2 to the 3rd, and then times 4. And then that's all to the 1/3. You don't understand that? 3 to the 3rd is 27. You don't understand why I'm doing it. 3 to the 6 is the same thing as 27 squared. But I can't do 27 squared. I mean, I guess I could, but I'm not going to. Yes. And I'm doing it because I can multiply these together now because they have the same base. That's really why I'm doing it. So my next step is on top I have 3 to the 1st times 3 to the 6. So total I have 3 to the 7 over 2 to the 12, right? And then that's to the 1/3. Now I'm going to put that 1/3 back in. So 3 to the 7/3 over 2 to the 12/3, which is 4. Now I can't find the answer to 3 to the 7/3, but 2 to the 4th is 16. So that's where I draw the line. That's where I'm done. Okay, that would be like the most complicated thing you'll have in your assignment. Your assignment is coming. you also have 2 XH bells before I see you again. You have 2 XH bells before I see you again. So if you need help, you have 2 XH bells before I see you again. And we have 25 minutes. It's not. You can sleep on Sunday. I got to start on Monday. No, you don't. You have 2 XHs before you leave. So you're going to do my homework for 25 minutes. And you could probably almost get it done. If not done. Give me lies like you're going to be doing my homework on Sunday. What do you think I do? On prom weekend? On prom weekend? You're going to do it on Sunday? Oh, the way you have XH on Monday and XH on Tuesday. No, you're not have to do it all. Put the numbers up. Okay, so the numbers that you are doing, because from worksheet number 1, you are doing all. From worksheet number 2, you are doing 1 to 12. That's it.
No, it's spilled everywhere.
What did you spill everywhere?
It was for my physics problem.
Something that's not in it?
No,
Or something you spilled in it?
it was in the video.
So there's not a mess to clean up?
No.
Okay. Last year when that kid had spilled his entire
Jordan? Or no?
Somebody spilled an entire Sprite during an exam, and then the floor after that was all like.
Earlier this year, it was kind of like first class, and then entire 2 meters when I posted sprayed all the way that way.
Yeah, there's just pain.
No, for like my physics project, like I have to fill up a bucket and like it falls and then it drops the ball and then something else happens. But like I guess we didn't like calculate right and like it fell and like it like tipped over and all the water fell off.
All right, so you have 1 to 21 on the first worksheet, and then on the second one just 1 to 12. But there, you will come across some that you're going to have questions on. So use this time wisely. Don't sit here and be texting.
I like
Whatever it is, I don't care. It's all the same. Send a message. Oh, that is right here.
Oh yeah, that was like the most exciting. It didn't have words like this one before the video, and like we were just getting the video. I know I'm really gonna sleep, like fall asleep and out. I need that sleep.
Okay, number 1. You got further than that one did.
Yeah, that's true. I remember this,
Well,
but
we did
I don't
three,
think
three.
I was good at it.
It was in our notes.
I feel like I remember not being good.
Specifically, no.
Yeah.
We put them in our notes. You don't need to. But then what does that happen? Well, then after doing all this practice, you should know about it. But if you need to create this on the test,
It's so cute.
you're not going to know how to do it because you didn't practice it. Okay.
Listen,
You can create your own list if you need it.
That's right.
You can multiply numbers. I wouldn't give you like 43 unless we practice it 20 times in class. I wouldn't give you that, but I'd give you so
Yes. On Saturday, which ones when you say stressful? Right.
I know, like, this is the second time.
Yeah, like every hour. Something that we in the morning.
If you're going to calculus next year, one reason why we're taking 2 whole block days to review all this stuff is this is where I've heard students are weak coming to calculus. They use it a lot. So that's why we're taking 2 whole block days to review this.
Tomorrow morning, an hour and a half away. An art show. In the morning.
I promote the time for you.
Yeah, I will, but like I'm there for it. At one because
You've got me.
it's so early in the morning, so we
You
punch
can sit here for
where you can do some things. And then, yeah, they have a hair
Okay, in the first 3 years. Well, I started rounding.
Yeah.
3 to the 5th. 6 to the
There's a point, I can do like this way, that's all. And then there's a point I have to. Like my brain literally just starts like, no.
So you have to take risks for that one. So you just check all these in your calculator?
No. That's
It's really. Just want to make sure we're so easy and do that feedback.
Yeah.
Okay, well, I made up an example that was like that. You write it down.
My mind can be nothing. You said that's so like, it's anything. Is, I mean, I'm not lying. 25 times 25 square. What's 25
Negative 5. Negative 5. 5 times 6. And then multiply that by 1.
Number 7 is 31.
There's some other numbers.
when I started that, I was like, oh wait, the negative.
And I'm doing stuff and I don't know what I'm
That would be amazing.
Isn't it negative? Yeah, I just gotta think. Too much work. I'm getting mine done in like long. For that. I was just saying it in my head. I'm buying about yeah, I got so much in this stuff. I was like, this year. Yeah. Because I didn't have to go on my ticket. I bought all my stuff. I paid for all my stuff. Did you use 2 different dresses? I used 2 different dresses. They were like $60 each. So I was gonna pay yeah. So I was like, I don't care. Yeah, mine won this. It's a little too kind of a little. When did your mom make your cake?
I mean, that can get expensive.
Yeah. Yeah, 12 minutes.
4. Where are you going? The guy?
Well, it can't be bad for the guy.
If you have the long slips, you're okay. If you have the short one, it is 12:38.
Oh no. My son was praying actually.
In my class got one, and the whole class just we were like, I'm waiting for last minute.
This class,
I knew like a minute ago that I had to go. My brother once said it was for laughing in class. Yeah, like a bunch of them were laughing. So she sent them out into the hall, and then someone came by and just gave them more attention. I was like, you don't have to. And she told him, she was like, I know if I heard it wrong, but I'll show anyone else, not you. I'm like, then multiply. How does that even work? You know, like, how to get this and multiply. You don't have to memorize. I mean, you have to know how to multiply. I'll use it like oh, I'm sorry. Overhead as a whole. Can you take it?
that was probably so hard to.
Yeah, but if you can't multiply, I don't know if you should have a result in it.
I can multiply all these.
That never.
I have, all the way. Everything that we've done, we've used multiplication.
I'm sorry, when you take it.
Like I've never used multiplication.
Oh, no.
I don't think you should be asking. Oh my gosh, that's so bad.
He said, well,
Oh, yeah. Don't be there.
No. Oh, yeah. Never had a detention, not even an option. In middle school. I never got one.
Oh, it is 4.
I got it one.
And it's 4 to 4. Oh, wait.
So they
You're like, that's not right.
yeah. Wait, maybe this like this, facing the wall.
Madeline got one.
I know.
I have a nice ring though. There's a table in the corner that you just sit down.
Aw.
No. I would cry.
I only had a stand from recess in 4th grade to finish homework.
I always wanted to stand just stand there and talk to people and I just want to go inside.
I don't
I
Well, I actually live my house is in, like, I can walk just go to my house, and if I just go through the woods, I could be at home. Yeah, it's like in my backyard, my elementary school. I do.
Hebrew 27 to the.
I went to the other day.
Yeah, because there's power for 1.
You should have.
Those are basic rules.
Why'd you go there?
I gave you harder ones first. Notice that.
My windows are always open. Gonna be on the probably honestly. Next time, I'll look on my window. Cause like I can see the people in elementary school, but I'm not.
For the root.
You just didn't write that one.
They almost stopped me at Washington. That you didn't like. I had to go back to my office last night, but I told this, Dig Mueller. I told her, and she got on the bus and got on the ground. I was like,
By yourself?
no.
My mom.
So like at the same time, we're like kind of like on the bus, we're five, but I
He also my dad is
And she almost left me and my dad
my dad is scouting.
Wait, you remember that?
It's just actually full.
It's just my dad remember she's scouting so early.
They talked about Yes, I do. You don't remember.
I'm sorry. Can you do that?
I either was on the bus
What's the square root of it?
Plus or minus.
So it's 1. Yeah, negative 1. Highway, you don't remember me writing to the bus? It's not about me.
Oh my god.
P33. I got extra. I don't think it's a square root, so. So what does that break up?